Welcome back to College Algebra, to our final video for section P7. We're going to be looking at simplifying complex fractions involving rational expressions. We'll also probably look at a complex fraction that involves just a fractional expression as well. So there are two general methods for looking at these. You can add, subtract, and divide. That is, a complex fraction is when you have fractions within fractions. I think we talked about them once in P2, where we had an example dealing with a numeric fraction within a larger fraction. So if you have rational expressions within a large fraction, you want to combine, through addition and subtraction, the rational expressions on the numerator. You want to combine the rational expressions on the denominator. Then you'll have one rational expression divided by one rational expression. So you can just do that division like we did in the previous video. The other option is to clear fractions. In that, we will find the LCD of all the smaller fractions, so all the fractions in the numerator, all the fractions in the denominator, and then we will take that LCD and multiply it through the numerator and denominator of the large fraction. So I'll show off both of those on an example. Let's take a look. This is exercise 77 from P7. The first problem, if you take a look there, we have x over y minus y over x and 1 over x squared minus 1 over y squared. You can see what I mean by fractions within fractions. Have this big fraction with the fraction bar here, the two smaller on the numerator, the two smaller on the denominator. Method 1, we need to get common denominators on the top, so that seems fairly simple. X over y minus y over x. Both denominators I can't factor any further, so their LCD is just going to be their multiplication. So I need another x here. To get xy, I need another y here. So that's just going to get me x squared minus y squared over xy. And on the bottom, I have 1 over x squared minus 1 over y squared. So, again, I can't factor the denominators at all, so I'm just going to multiply by the piece I don't have. Y squared, x squared. That'll be y squared minus x squared over x squared, y squared. So now we're just doing a division. So I have x squared minus y squared over xy divided by y squared minus x squared over x squared, y squared. That's going to be x squared minus y squared over xy times x squared, y squared over y squared minus x squared. Oh, I forgot my squared there. Alright, first off, this xy will reduce away and I'll get rid of these squares. Then, if you'll notice, x squared minus y squared minus x squared are the same factor but with opposite signs. So I factor out a -1 from this one down here, get x squared minus y squared. Then I can reduce that away and I just end up with xy over -1 or negative xy. And we're done. I think I actually miswrote this problem. I think it was supposed to be 5s here on the denominator, but the only difference that'll make will be I'll have a 5 at the end. It'll just carry through. Here's a return of a problem we haven't seen really since P4. Rationalizing the denominator. This is a trick you can do when you have two roots. In P4, previously we would have tried to do, in P4 we had problems like this. We had like 3 over the square root of 5. And you could get rid of that by multiplying top and bottom by square root of 5. Rationalize denominator. means get the root off the denominator. And that would have got us 3 root 5 over 5. That's not adequate here because, say, if I multiplied by square root of 2 over square root of 2, it would distribute through. So it would go away in the first term, but it would just show up on the second term. You might say, well, I just multiplied by itself over here. Why can't I multiply by itself here? Fortunately, it's not that simple. Unfortunately, it's not that simple. Because if I multiply by square root of 2 plus square root of 7, I'll just ignore the numerator for now. That's going to be 2 plus 7, but you've also got the cross terms. So it'll be plus square root 14 plus square root 14, and I still have a root on the denominator. Now what I need to take advantage of is this old factoring or multiplication formula. A squared minus b squared is a plus b times a minus b. If both roots get squared, the roots will go away. That'll solve my problem. I already have a plus b, so I just need to multiply by a minus b, and it will solve my problem. Square root 2 minus square root 7, square root 2 minus square root 7, and we will end up with 2 times square root 2 minus square root 7 over 2 minus 7. And that's going to be 2 times square root 2 minus square root 7 over negative 5. That's probably fine for the answer, but usually I would take that and pull it out front, or put it up there with the 2. So negative 2 times square root 2 minus square root 7 over 5. Another way you could write it that's probably a bit more elegant is you could also just distribute that negative into the parentheses and have 2 times square root 7 minus square root 2 over 5. Really, all three of those should be accepted as answers. This last one, this last problem we're going to look at from this section, is kind of a tricky problem. This is an expression that often arises in calculus, and we're going to do some interesting things to it to try and simplify it. First off, oh, I forgot. I'm sorry. Back here, I forgot to do method 2. Method 2 is to find an LCD of all the denominators, so that would just be x squared y squared, because the furthest you can factor down is x and y, and the highest powers they had were x squared and y squared. And you take that and multiply it into the top and into the bottom. Sorry, I forgot this. This is method 2. So if I multiply x squared y squared into that first fraction, x squared y squared times x over y will just get me x cubed y. X squared y squared times that second one there will just get me one of the x's will cancel out. Oh, sorry. X squared y squared plus y times y over x. So that'll be xy cubed. X squared y squared, oh, that'll be easy. X squared y squared times 1 over x squared will get me y squared, and then x squared y squared times 1 over y squared will get me x squared. So I'm going to have x cubed y minus xy cubed over y squared minus x squared. And then I just try to simplify that. So if you pull out an xy on the top, so you got common. You'll end up with x squared minus y squared minus x squared. And as we've seen before, these are just opposite signs, so I just factor out a negative from one of them. They would reduce away, and I'd end up with negative xy. Sorry, I forgot. Method 2 I often find is faster to write. But method 1 has the advantage of, I think it's more understandable. It follows pretty much exactly what you've been doing before. It just takes a little bit more writing to do it. So it really kind of depends upon your mindset. Some of my students really hate writing out the full description, and they tend to prefer that, even if it means they make more mistakes because they don't have as much understanding. So it's really up to you. Here, I think I'm actually going to start with method 2. There's only fractions in the top, so I'm going to clear those. Find my LCD would be, can't factor that any further, square root x plus h. Square root x. So I multiply that into the top. And the bottom. That's going to get me square root x minus square root x plus h on the top. And on the bottom, h square root x plus h. Square root x. Then I'm going to apply one more trick. I'm going to rationalize the numerator. Most problems ask us to rationalize the denominator, but you can rationalize the numerator the same way. I have a minus b, so I multiply by a plus b, square root x plus square root x plus h, and I'll get a nice result. I'll get something that will reduce after I do this. So on the top, we're going to get x minus x plus h. On the bottom, we're going to get h square root x plus h square root x, and then times square root x plus square root x plus h. Oh, don't need that. So on the top, you have x minus x, that'll go away, and you have negative h. And on the bottom, I'm just going to write the h and then the other stuff. The h will reduce. So my final version of this is going to be negative 1 over, add a square root x plus h, add a square root x, add a, in parentheses, square root x plus square root x plus h. And that's the most I can simplify this type of fractional expression. So that is going to finish us off on section P7. I think you'll like P8 quite a bit more, because P8 is just solving basic equations. We'll look at that next time. So I will talk to you then.